Hi everyone, today we're going to be talking about the distance and midpoint formula. Today, our objectives are that students will be able to find the distance between 2 points and find the midpoint of a segment. Let's get started. Alright, the distance formula. So we use the distance formula to find the distance between 2 points. When we have one point, we call it x1, y1, and another point, x2, y2. When you see the little one down below, we call this a subscript, and we would just read this as x1, all right? It's not, or you could read it as x sub 1, all right? But in simpler terms, it's just x1. This right here is not x squared. That's just x2 because it's a subscript 2, not a superscript. It's not an exponent. All right, now the distance formula is important, and I I definitely think you need to memorize this, all right? So this is something you need to memorize. Distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so this is something you need to memorize. We're going to be using it a lot, all right? All right, here's an example where we want to find the distance between the 2 points on this graph. So the first thing we want to do is identify the 2 points. So this point right here, all right, that's going to be our first point. That's going to be our x1, y1, and our x value is at -5, y value is 3. So that point is -5, 3. Our second point is this point right here, and if we were to write this as an ordered pair, it would be -2, -3. Now we're going to identify each of these, and we're going to label them. We're going to call this one x1, the 3 is our y1, -2 is, x2, and y2. All right, now we need our distance formula. We're going to write it down because we're going to use it. Distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now we're going to take each of these values and substitute them in. So we've got the square root. We know x2 is -2, so we substitute it in, minus x1 is -5 squared plus y2, we labeled it, and it's -3, minus y1 is +3 squared. All right, now we're just solving. So we want to simplify what's inside the square root, so inside the parentheses. So -2 minus a -5 is the same thing as +5. So -2 plus 5 gives us +3 squared plus -3 minus 3 gives us -6 squared. And then we keep simplifying. Let's see if I can make this smaller. All right, equals the square root. 3 squared gives us 9 plus -6 squared gives us 36. 9 plus 36 gives us 45. All right, now the square root of 45, we want to plug that into our calculators. When we plug that into our calculator, we get that the square root of 45 is approximately 6.7, and that would be our final answer. By the way, this little squiggly equal sign means approximately, all right, in case you didn't know that. All right, number 3, we're given that this line segment EF, and we're given the 2 points. We're given both endpoints, E and F. We want to find the distance between those 2 points. So we're given our points, and we want to label them. This will be our x1, y1, x2, y2. All right, now we're going to use our distance formula, so we copy it down because we need it. Distance equals x2 minus x1 squared plus y2 minus y1 squared. Then we're going to substitute our values in. All right, so distance equals the square root. x2 is 11 minus x1 is negative 7 squared plus y2 is 3 minus y1 is negative 2 squared. Then we're going to simplify what's inside the parentheses. So 11 minus the negative 7 is the same as plus 7. So we've got 18 plus 3 minus a negative 2 is the same as plus 2. So we get 5 squared. All right, now we want to use our calculators because I don't know about you, but I don't know what 18 squared is off the top of my head. So when I plug that into my calculator, 18 times 18 or 18 squared, we're going to get, let's see, 324 plus 5 squared, we should know that off the top of our head, 25. Add them together, we get the square root of 349. Then we plug that into our calculators, square root of 349, and we get that that's approximately 18.7. And you can just round to the tenths place, 1 decimal. All right, and that's your final answer. All right, now the midpoint formula. The midpoint formula is used to find the midpoint between 2 points. So it's used to find that halfway point, what cuts the segment directly in half. That's the midpoint. So the formula we use for that is m equals, and we use parentheses because it's going to be a point. We say x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Basically, what you're doing is you're finding the average of the x values and the average of the y values, because we're adding the x values together, dividing by 2. When you're finding the average of something, you add them together and divide by the number of items you have. All right, so what we're saying is we're adding the x's together, divided by 2. We're finding the average of the x's and the average of the y's, and our final answer is always going to be an ordered pair, x comma y. All right, here's an example. We want to find the midpoint of line segment AB given the two endpoints, A and B. So just like with the distance formula, the first thing we want to do is label our points. So we've got x1, y1, x2, and y2. Then we're going to use the distance or the midpoint formula. So we're going to copy it down. What is our midpoint formula? x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Then we're going to plug our values in. So our midpoint is going to be x1, which is negative 7, plus x2, which is 3, divided by 2. y1 is 4, plus negative 4, divided by 2. Then we're going to simplify. Negative 7 plus 3 gives us negative 4 divided by 2. 4 plus a negative 4 gives us 0 divided by 2. All right, now we're going to simplify this, all right? And negative 4 divided by 2 gives us negative 2, and 0 divided by 2 gives us 0. All right, just a quick mini lesson on 0 with division. All right, if 0 is on top, all right, that is okay. 0 divided by anything is always going to be 0. And if you guys want to look to the front of the board at the top of the room, all right, above the meme board, there's the little signs that say okay and no, all right? This is my little trick to remembering if I can divide by 0, whether 0 is on the top or the bottom. If 0 is on the top, it's okay, all right? That means you can do it. You always get 0. If 0 is on the bottom, nope, you cannot do it. No, no, no. It's a no-no. You cannot have 0 on the bottom. If you have anything divided by 0, you get undefined as your answer. Or if you were to plug it in your calculator, you would get an error. All right, so think of k and n as variables, just letters standing for any sort of value. If 0 is on the top, it's okay. If 0 is on the bottom, it's a no-no. And then our final answer should be negative 2, 0. That's the halfway point between those two endpoints, or our midpoint. All right, here's where it gets a little bit tricky, so I highly recommend you pay close attention to these next few examples. All right, so number 7, we want to find a missing endpoint. So we want to find the coordinates of J if we're given that K is the midpoint of JL, and L has the coordinates of negative 8, 6. So first thing I want you to do is draw a picture. If we've got a line segment, and we know this is J and this is L, we're looking for J, and we're given K is the midpoint. And we know K is the midpoint, and it's negative 5, 10. And L has the coordinates of negative 8, 6. All right, obviously this wouldn't be a horizontal line if we were to plot these on a graph. All right, it would be at a diagonal. All right, but for now we're just kind of getting an idea of what we're looking for. All right, we're looking for J, so we're looking for an x comma y. We don't know what it is. Now, with our midpoint formula, we know our midpoint formula is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. Now, midpoint is an x comma y, right? Our m is going to be an x comma y. So if we want to replace m with x comma y, we can do that. All right, so we can say that midpoint is an x comma y because we know our final answer is going to be x comma y. Now, we know that negative 5, 10 is our midpoint. That's our x comma y. That's this value right here, negative 5 and 10. We also know that L is one of the endpoints. So let's call this x2 and y2. And we're looking for x1, y1. We don't know what they are. So if we were to substitute negative 8 in for x2 and 6 in for y2, let's do that. We still don't know what x1 is. That's what we're looking for. But we know x2, or our second endpoint, is negative 8. We don't know what y1 is, but we know that y2 is 6. All right, so now we've substituted in the values that we do know. Okay, what we can do is we can say that this is going to be our x value, and we know this is our x value because there's an equal sign in between here. So we know that this has to equal this. And this is our y value, and we know this is going to be our y value because it's an equal sign. So this has to equal this. So what we can do is write two separate equations representing this. So we can say that negative 5 equals x1 minus 8 divided by 2. All right, and we can say that 10 equals y1 plus 6 divided by 2 because that equal sign in between. All right, a equals a, b equals b, x equals x, y equals y. All right, now we can solve these equations separately, and we can solve for x1 and we can solve for y1. All right, so I'm going to get us some more space here. So now solving for x1. In order to get the x1 by itself, first thing we need to do is multiply both sides by 2. So we get negative 10 equals, these 2's will cancel out, x1 minus 8, add 8 to both sides, and we get that, let's see, sorry, I'm trying to get some more room but still be able to see everything. And we get that these will cancel out, so negative 2 equals x1. Then to solve for y1, multiply both sides by 2. So we get 20 equals y1, these will cancel out, plus 6, subtract 6 from both sides, 14 equals y, or y1. Now you found your x1 and your y1. That's this point right here, that's your j, and that's what we're looking for. So j is going to be always an ordered pair, x comma y, -2, 14. And that would be your final answer. Alright, so I know this sounds a little tricky, but always remember when we got to set it up, plug in what we know, and solve for what we're missing. Alright, if you have any questions on this one, either go back and re-watch this example or call me over so I can help you out. Otherwise, let's move on. Alright, number 9. We're given that P is the midpoint of X, Y. So first thing we want to do is draw a picture. We've got X, Y, and P is the midpoint. We're given that XP equals 8X minus 2. And we're given that PY equals 12X minus 30. We want to find the value of X, alright? And also because P is the midpoint, that means this segment is congruent to this segment. That means it cuts it in half directly, alright? So XP is congruent to PY, or they're equal, the same distance. Now if we want to find the value of X, all we need to do is set them equal to each other. We've got an equation because we know that XP, or 8X minus 2, equals 12X minus 30. Now we're just solving for X. It's just algebra from here. So subtract 8X. We want to get all the X's to one side. These will cancel out. -2 equals 4X minus 30. Move the 30 over to the other side. So we add 30 to both sides. Alright. We get 28 equals 4X. Divide by 4. And X equals 7. The problem's just asking us to find the value of X, so we're done. Alright, the last example we're going to do today, number 11. So using the diagram to the left, if line N bisects QR. So line N is a segment bisector. Alright, so it bisects segment QR. That means it cuts QR in half, so P is the midpoint. We want to find QP. So if P is the midpoint, that means QP equals PR, or 3X plus 5 equals 5X minus 19. So we can write out that equation. 3X plus 5 equals 5X minus 19. Now we can solve for X, and then once we solve for X, we can find QP by just plugging it back into 3X plus 5. So first off, let's solve for X. So we want to get all the X's to one side. These will cancel out. 5 equals 2X minus 19. Add 19 to both sides. These will cancel out. We're left with 24 equals 2X. Divide by 2, and X equals 12. Now, that's not our end goal here. We're not trying to find X, we're trying to find QP. So we have to go back and plug it into 3X minus 5. So, let's get some more space here. To solve for QP, we know that QP equals 3X plus 5. So we plug in X. So 3 times 12 plus 5. 36 plus 5. So QP equals 41. And now you're done. That's what we were looking for. We were looking to find the length of QP. Alright, so I hope you learned a thing or two about distance and midpoint formulas today. If you have any questions, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.